Hey guys, today we are going to learn about what is called a partial fraction decomposition. And what we're going to be doing is we're going to be taking fractions and we're going to be breaking them down into two parts. And before we go into the formal demonstration and examples, we're going to start with what if they are already broken apart? How do we put them back together? And then we're going to reverse the process. And our goal will be at the end of the day to solve for constants. Okay, and what are the values, the original values? So reversing the process of putting them together. Okay, so let's just review some of the process of adding fractions. So when we put together two fractions together, think about the only way that we can put them together is that they have a common denominator. So what would you do? All right, so to put these together, we'd have to find the least common denominator. In other words, what is the smallest number that both of those numbers divide evenly into, and that would be 40. So what would you do to this first fraction? You would have to multiply the top and the bottom by 8 to give you a 40. All right, and then what do we do to this fraction? You'd have to multiply the top and the bottom by the 5 to give you a 40. All right, so to do that, you would have 8. Whoops, this is a little bit big. I probably have to make it smaller. Zoom back this way might work. Sorry, guys. All right, so what do you do? You're going to multiply the first fraction by 8 over 8. And you're multiplying this one 4/5. And then you would multiply this one by 5 over 5. And then that would yield your 32 over 40 plus 15 over 40, which would give you 47 over 40. All right, so now that is just working with constants or working with numbers that don't have variables in it. But in this one over here, if you were to find a common denominator, I know some teachers teach us by doing cross multiplication, by taking this number, multiplying by the top and bottom of this fraction, and then taking this and multiplying it by the top, which is essentially multiplying this fraction on top and bottom by x plus 2. So you are giving each of the fractions its bottom, okay, its denominator. All right, so combining both of those together, that would yield, if you were to take this top and the 3 and multiply those on the left-hand side, you'd get 3 times x plus 4. And then doing the same thing over here, multiplying the x plus 2 times that negative 2 will yield a negative 2 times x plus 2, all divided by the least common denominator of those two put together. Okay, so we did a little bit of that in the last chapter, a little bit with common denominators. Okay, all right, so this is putting them together, but now what we're going to do, and for each one of these, you would, of course, this would be simplified together. You would distribute, and we're not too worried about that. But the whole process of what we're going to be doing is we're going to be given something like this, and we're going to go backwards in time. And our goal here is, what were the original two numbers on the top? Okay, so that's what our goal is. It's called a partial fraction decomposition. So here's another example. At the end of the day, our goal is to take something like this and ask ourselves, or try to derive this at the very end, what are the two constants over here? And keep in mind, now remember, we're working with factors. If you were to factor this out over here, it would factor into x minus 3 and x plus 2, and those are giving you the two partial fractions that you started out with. So if you go back to this other example, if you recall, you had originally two partial fractions that we put together as one. And again, this would simplify down at the end of the day. All right, but this over here is exactly what we're going to be doing. We're going to be starting with the combined and trying to find those two numbers here. Okay, so we're reversing the whole process. All right, so I'm going to give you a step-by-step process of how we're going to go about doing this. So everything on this first lesson that we're going to be doing, I did break it into 2 lessons. The first lesson, all of the factors on the bottom, so all of these down below, they're all going to be what we call linear factors. So everything, all of the x factors are to the first degree. So I'm just kind of emphasizing first degree after factoring. Okay, again, the factors are linear factors, not the original trinomial, all right, on the denominators. Okay, so what we're going to be doing is the very, very first step, and you're going to keep referencing this box over here to remind yourself what you have to do for the step-by-step and follow your notes, of course. Start by taking the denominator, and in order to break it apart, you have to rewrite it as a product of factors. So that's our first step. All right, and there is a little stipulation here in order to do this process for the 2 lessons that we're doing. All the ones we're going to give you is the degree of the numerator is less than the degree of the denominator. Okay, all right, so once you have broken it apart, so we're going to break all of the factors down into a sum of fractions with the denominator as representing one of the factors. Okay, now if you get any repeat factors, so let's say you have x plus 2 raised to the 5th power, you are going to have to give you're going to have to give a fraction to each one of those factors. So you have your x plus 5 to the 1st power, x plus 5 to the 2nd power, to the 3rd, all the way up to however many I just said there would be. So you would have that repeated, and we're going to show you many examples of that as we progress if we have multiple factors of the same one. And on the numerator, you're going to assign it a constant variable. We typically will use A's and B's and C's for the numerator. We are trying to solve for the numerator, so we're going to assign it some variable. Okay, and we will, again, as we progress through our notes here, you'll see how that works. All right, but the main thing is that the numerator is going to be, for all of these, a constant, and the denominator is going to represent one of the factors that our denominator will factor into. The step 3 is to go through the process of solving, and there's going to be 2 different ways through our notes for the next couple of sessions here of how we are going to do this. One is we're going to use convenient values. All right, so kind of like guessing or figuring or just looking at the equation, what would be an easy value to plug in that will yield a 0 for an answer to wipe out one of the variables. So we're going to do that method. And another method is what we call expanding and doing a little bit of a matching game. All right, so this one sometimes on the front end might be a little bit harder, but it works 100% of the time. Okay, so it takes, you can be very systematic and do this on every single one, okay, or you can do this little guessing and let's look for some convenient values. All right, so that one works well. And then at the very, very end, once you have solved for each one of the constants, then we will go ahead and substitute those back in. And just like when you're solving y equals mx plus b, once you get the slope, once you get b, then you have to put it back in to your general form and identify what the final equation is with those variables in it. Okay, the values of those variables. All right, so the first thing we're going to do is just get a little bit of practice on recognizing the linear factors and getting us set up if we were to actually solve. We're not going to solve, we're just going to really just get set up. The first step involved when actually going about to solve the problems. All right, so the step 1, if you remember step 1, so we're just going to do the first part is this right here. We're going to factor the denominator and then we're going to get set up in this format because that's the first thing. If you don't have this set up properly and you don't recognize how to set that up, then you will not be able to go any further than that. All right, so step 1, you ready? Step 1 would be to, and that's all I'm asking you to do, is I'm going to start by having you just rewrite the top. Always just write the top as it is, and now we're going to factor the bottom out. If you remember how to factor, what 2 numbers multiplied together will give you a 3, but add or subtract to a negative or positive 4, and that would be a positive 1 and a positive 3, so that's our first step. Now notice that these are the two factors that when multiplied together will give you this. All right, so that's your first step. Break it into factors so we can then break it into multiple fractions that will eventually add up to this. Now, when you do this, also, we're working with linear factors. If you notice, x is to the first degree and x is to the first degree. So this is what we call a linear factor. So once it's already broken down to the factor form, make sure these are to the first degree. Okay, the next lesson that I'm going to show you, those will not be the first degree, but we're going to only focus on linear factors here today. Okay, so once you have done this now we can break it apart. So if you remember, when we put them together, you started out with, and this one it would be two fractions. One of the factors is x plus 1. The other factor is x plus 3. Okay, but we do not know what the original constants were, so we're just going to assign this an A and a B. Okay, so that is all we want you to do. Break it apart. All right, break it apart, and in the next section, we will actually solve something similar to this. All right, so this next one, keep the top exactly how it is. Factor the bottom. So you're just practicing factoring here, and you get x plus your 9. All right, all I did was I pulled an x out. And notice once again that these are all linear factors. In other words, they are to the first degree. All right, so once you have done that, again, now we're reversing the process. You're going to take each of the factors and give it its own fraction. So x gets its own fraction, and the other factor, x plus 9, gets its own fraction. And I do recommend you putting parentheses around the binomials. And then again, what our goal at the end of the day is, what were those constants? We're going to call one constant A and the other one B, and voila, that's all we want you to do. Stop right there. Okay, let's do another one. The bottom is already factored, so we can just go right into the next step. All right, so this is already the product of number. Factoring means a product of numbers. This is already being multiplied. Now look what you have here. You have 2 to the second power. All right, so we're going to talk about that. We're going to get ourselves set up. Give each of the factors its own fraction. Now be careful here. You have x plus 5 to the second power. Now if you go back to our little notes up here, notice that these are increasing factors of px plus q. And if you have, let's say, 5 of those factors, then you would have to increase. That's how many fractions you're going to have of that factor under giving it its own fraction. So over here, you have x plus 5 to the second power. All right, so one fraction is going to need x plus 5 to the first power, and then you need another fraction because one of those factors could also be to the second power. So we do need to include both of those. Notice all I did is I wrote what is how many the original factor, and then you're going to count, you're going to increase factors up until as high as it goes. Okay, so if this was a third degree, you would have one more x plus 5 to the third degree. And then if it was to the 5th degree, you'd have to have 2 more after that. Okay, so now the question is, what is the A, the B, and the C value? All right, and we're going to learn next how to do that. Okay, so let's try a couple of these. All right, so we have 2 of these that we're going to be doing today. We have A and 3, I lied. All right, so we have 3 of those to do. Don't write too big. It does take a little bit of space here, so we're going to want to make sure that we leave some space. All right, so the first thing we're going to do is we're going to factor. All right, step 1, factor. So we're going to rewrite this just like we did above. Notice the bottom, you can pull that x out, and that would yield x minus 3 for this factor here. All right, so that's your step 1. Step 1, I'm going to call it S1. All right, so step 1, factor. The denominator, not the top, just the denominator. All right, so now we're going to move on to step 2. All right, so step 2, give yourself some space here. Now we're going to set up the form just like we did in A, B, and C above. Okay, so what we're going to do is we're going to start by writing the original factored, however. All right, what you have in step 1. And then we're going to set that equal to the format. You're going to give every single factor its own special fraction. So you're going to put x all by itself plus, and you're going to put x minus 3 all by itself. All right, and now you're not going to do anything with that 6. You're just going to leave it alone on the left. Okay, so the left-hand side is the original factored, and then the right-hand side is the expanded form, giving each of the factors its own fraction. All right, so now we're going to put an a here and a b here. So those are the constants. And what I want you to notice here, and this is something that will always be true, is if this is a linear to the first degree, this on top will always be a constant. In other words, there will not be like an x with it. In the next one, this is potentially could be a quadratic that doesn't factor, and things are going to change. So, but just kind of start to note some characteristics, some observations. Okay. All right. So now our goal here, we're not only are we going to write the format, but in this step here as well, we're going to clear the denominator. Our goal is to solve for a, okay? And b. So in order to solve for a and b, we're solving an equation that has a fraction. No one likes fractions, so how are we going to get rid of those? You're going to clear the fractions denominators by multiplying every term by the LCD, the least common denominator. All right, so I'm just going to write over here, LCD, and then we're going to clear denominator. Clear denom. I'm just going to abbreviate. All right, so what I'm going to do over here, I'm going to just put parentheses around the whole entire equation, and I'm going to multiply the entire equation by the least common denominator. And if you look over here, this factored original denominator is always the LCD. Okay, so make note of that. So I'm going to multiply by x times x minus 3 and make sure that you keep that as factored form. All right, so now what we're going to do is we're going to take every single term in the entire equation and I'm going to multiply it by the LCD. So I'm going to multiply that, and this by x times x minus 3. All right, now pay attention very closely here. So when I take the left-hand side, the original, and I multiply it by its own denominator, what ends up happening is all of this wipes out with all of that, and what 100% of the time with the left-hand side of what's going to happen is what's left over is the numerator, which is 6. So I'm just going to put that 6 right here. Okay, so all I did is I took this and I multiplied by this term. The bottom will wipe out with that, and you get 6. Okay, so now let's proceed to multiplying the second term by x times x minus 3. So watch what happens here. So when you take this and you multiply by this term, now keep in mind, these are factors. I can take this x and it'll wipe out with that x, and what's left over is your a and the x minus 3. But the denominator is now wiped out. Okay, and you get 8a times x minus 3. Now we're going to proceed to the next one. You're going to take x times x minus 3, and you're going to multiply by the very last term. The x minus 3 wipes out with x minus 3, and what's left over is bx. And that's your whole goal, is to wipe out the denominator. So what I have left here is this simplified, cleared denominator of your expanded form above. Okay, so isn't that much easier? It looks much nicer than what we had. There is no longer any denominator. No one likes fractions. Okay, so now the next step, what we're about to do is now we're going to take that simplified equation. Our goal here is to solve for a and b. And if you noticed above, there's two different ways that we're going to be able to solve this this problem. We can do what's called convenient values. And what I'm going to recommend is at any time that you can solve using convenient values, do it. It's much easier. Okay. And we're going to talk about using systems or it's called matching parts. for another method that convenient values are not possible. Okay, so here's what's going to happen. What it means to do a convenient value is your goal here is, again, at the end of the day, to solve for A or B. And you're going to ask yourself for step 3, we're going to call this S3, you're going to solve for A and B. And what we're going to use convenient values. All right, so you're going to ask yourself, all right, well, what are you talking about? Convenient values. You're going to ask yourself, is there any number that I can plug in for X that would wipe out one of the two variables? All right, so for example, if you remember when you're finding zeros, you're asking yourself, what can I plug into an equation that'll make something poof out and disappear completely in hopes that just one of the other variables is left over? So if you notice, let's start with an easy one. Think about if you let x equal 0 right here. If you let x equal 0, what happens to b? It poofs away. And what's going to happen? You're going to be left with an equation that has just one variable in it. Voila, you're going to be able to solve for a. Or, how about this? What if you would have put a positive 3 right here in this one? If you put a positive 3 over here, look what happens to a. It wipes out of the equation. And now you would be left. Now keep in mind, you're putting a 3 here as well. Okay, you're putting a 3 here as well. And I probably should have said that in the last example. But you're putting a 3 here as well, which would allow you to have one variable remaining. So this is a perfect example where we can use convenient values in order to wipe out another variable and be able to eventually solve for those two, A and B. So are there any convenient values? Yes, there are. We're going to let x equals 0, and we're going to let x equal to a positive 3. All right, so we're going to do that in both of these cases. So let's go ahead and do that. So I always write down what you're doing. Let's start with letting x equal to 0. All right, so what you're going to do is you're going to rewrite this equation above. In this equation, all right, we're going to let x equal 0. So you have 6 is equal to a times 0 minus 3 plus b times 0. Well, what did that give us? Well, if you look at that, it wipes this one out, and you end up with 6 is equal to a times negative 3. And when you solve for a, you're going to divide by negative 3, and a is equal to negative 2. All right, so look what you have. You have your a value that's going to go right there. We're halfway done. All right, now all we need to do is get our other variable. So now we're going to go ahead and do another convenient value. The first one was let x equal 0. Now we're going to let x equal to 3. And we're going to do the exact same thing. And we're going to substitute 3 in for x. So now you have 6 is equal to a times 3 minus 3. Okay, and now keep in mind that we also have, all right, let's keep going. Hold on. Let me see. I'm about ready to say something, and I need to back up. Then you have b times your 3. Sorry. All right, I'm not going to go any further than that. All right, here we go. Sorry, I'm talking in circles, you guys. I think I saw a squirrel. All right, so 3 minus 3 is 0. All right, I'm being a silly girl here. All right, 6 is equal to b times 3. And then you would go ahead and divide by 3, and b is equal to 2. Okay, and there you have your two variables. All righty. And the very last step, when you're all done, I didn't leave myself a whole lot of space over here. But we're going to go on to step 4. You're not done. You just don't stop there. It's just like finding the slope and the y-intercept and stopping. All right, we're not done. The final step is now, what is the partial fraction decomposition? You're going to go ahead and you're going to substitute a and b, and you're going to put it into this equation right here. All right, so we're going to take that, the two values in our partial fraction decomposition, the original equation. We can leave it factored, or you can go back to the original It doesn't really matter, but that equals A. You're going to put negative 2 over x. And again, I am substituting it right here. I'm taking A, putting it here. I'm taking B, and I'm putting it there. And I'm just rewriting the whole equation. And that's plus 2 all divided by x minus 3. All right, so that, my friends, is your final decomposition. We found the two constants that would yield that original. All right, so one thing I do want you to keep in mind when you guys are doing this, there was really nothing that said, when I first asked you to take the factors and assign it its own fraction, it didn't matter if you put x minus 3 here and x here. That didn't matter. So keep in mind, if you would have done that, then your A and B, this would still be A and this would be B. But these two complete fractions could be in a different order. So when you go to check your work on something like this, if you had 2 divided by x minus 3 in this position and this over here, it's okay. There's nothing wrong with that. All right, and we know that is your commutative property of addition. These two, 4/5 plus 3 over 8 is the same thing as 3 over 8 plus 4/5. So those can be interchanged. All right, so don't panic when you go to check your work, and your decomposition might be in a little bit different order. But what you do have to have is above x must be partnered with negative 2, and this 2 must be on top of the x minus 3. Okay, let's try another one. 2 more. All right, step 1. Ready? All right, here we go. Here's our goal. Our goal is to break this apart into partial sum fractions. Step 1 is to take this, keep the top exactly how it is, take the denominator and factor it. This factors what two numbers multiply together will give you a -6, but we'll add up to a -1. And hopefully you see that that is x plus 2 and x minus 3. All right, so that is your step 1. Again, factor only the denominator. We'll just do that. Okay, ready? Step 2. Step 2, we're going to get our form set up. So I'm going to just call it form and LCD. All right, so you're going to take this. You have x plus 1 all divided by, you're just rewrite it, x plus 2. Sorry, guys, I'm really tired. All right, but I'm going to try to get this done for you for tomorrow. All right, and then you're going to give it its own fraction. You have x plus 2 plus x minus 3. All right, so all I did is take the factors on the bottom, assign it its own little special fraction, and then we're going to assign the top a variable. I like A and B. All right, and then once you have the form all set up, now we're going to solve for A and B by clearing the denominator. And remember how to do that. You're going to take the original factor. This is always your LCD. And you're going to multiply both sides by that LCD. All right, and you have your x plus 2 times your x minus your 3. And remember, you're going to take this whole thing and multiply it by the first one, the second one, and the third one. And you will have gotten rid of all the denominators. Beautiful, beautiful. So you're going to take the first fraction, multiply it by this, and they're identical, so they wipe out. And remember, on the left-hand side is always going to be the original numerator. Okay, now we're going to go ahead and we're going to multiply the second fraction by all of the LCD. X plus 2 wipes out, and what's left over is A and x minus 3 on top. So you get A times x minus 3. And then you're going to multiply the third fraction by the LCD. The x minus 3's wipe out, and what's left over is B times x plus 2. Leave it in parentheses. Okay, and I do like to always box that out. You'll see that I've been doing that, and I will continue to do that. I'm just going to Bring that up a little bit. Okay. All right, so once you get to this part over here, once again, my step, oh, this was a 2. I can't count. This is a 3. Step 3 is now I'm going to solve, and you're going to ask yourself, are there any convenient, that doesn't look right. I'm just falling asleep here. Wake up, Holbrook. Values. Lack of sleep last couple days, but we're going to do this. All right, convenient values. Is there a value that you can substitute in for X that will wipe out either A or B? Think about it. I think I see a couple. If I let X equals 3, this will wipe out. If I let X equal -2, this whole B would wipe out. So I did find 2 values. So yes, convenient values would be X is equal to 3 and X is equal to -2. So I'm going to go ahead and get set up, and I'm going to solve. I'm going to show your work, X equals 3 over here, and I'm going to let X equals -2 over here, and I'm going to proceed to solve. Okay, so I'm going to do it twice. All right, so let's go substitute in. Ready? Go ahead. You guys do it without me. Try to catch up. All right, 3 plus 1 equals A times 3 minus 3 plus B times 3 plus 2. And you can pause me and fast forward me. You might get through a little bit faster if you want. That goes to 0. And this becomes 5B. Don't panic. Don't panic. Did something wrong? I got a fraction. Nope, you're good. You get 4/5. Good to go. Nothing wrong with that. All right, now we're going to do the next one. We're going to let X equals -2. -2 in the left plus 1 is equal to A times -2 minus 3 plus B times -2 plus 2 and 0. Wow. -1 is equal to, whoopsie daisy, lost a parenthesis. Sorry, I'm talking to myself. I like talking to you guys better, but this is all I got right now. All right, A is equal to 1/5. All right, there you have it. Yay. Mission accomplished, but again, don't forget to substitute them back in. So your very last step now would be to substitute into your equation above. All right, so we're going to take those. And again, this is step 4. Step 4, sub. We're going to call it substitute, whatever you want. Sub. And you have the original is your x plus 1. Again, you can either do the original x squared minus x minus 6, or you can write it as the factored form. It really doesn't matter. What's important is, honestly, the right-hand side. All right, so A, we have 1/5. Make sure you put it into the right one with the x plus 2. Plus B is 4/5, all divided by x minus 3. All right, now this is a little top heavy, you guys. You remember the keep it, change it, flip it? Well, guess what we're about to do? We're about to keep it, change it, flip it. All right, so we're going to keep the top is 1/5. Is it right, 1/4? 1/5. All right, we're going to change it to multiplication. And x plus 2 flipped is 1 divided by x plus 2. All right, we're going to do the same thing over here. Keep the top, change it to multiplication, and instead of x minus 3, it's 1 over parenthesis x minus 3. And then that simplifies down to 1 on top, and then 5 times x plus 2 on the bottom. And over here, 4 on top, and then 5 times x minus 3 on the bottom. All right, so this over here is one potential way that you can write this. But if you notice that the denominator has a 5 in common, very often what some of the textbooks will do is they will pull that 5 out, and really what you're pulling out is a 1/5. Okay, they both have a 5 in the bottom in common. And by pulling that 5 out, you still have a 1 left on top for this first fraction, and you still have a 4 on top on the bottom in x minus 3. So this is going to be another common way. So if you're going to check your work and my answer key has the bottom one or the top one, and you did this, understand that those are the same thing. So I would accept either one of these. Let's say this was an assessment, but on a final exam, very often we like the bottom one as well. Okay, but really it is the same, but just different format. And there's your partial fraction decomposition. One more for this set of notes. Let's just see if we have this. Let's go ahead and do this. And this is second way. I think what I'm going to do is I am going to end up on using a different method to solve this one. I'm going to show you a method that in some problems when you don't have convenient methods or convenient values, you will have to expand. And it takes a little more upfront work, but some people like doing this 100% of the problems. Some people don't like convenient values. So this is going to be another option. Part 2 of this video is going to do a lot of this method. This is a very basic one, but let's go ahead and do it. All right, so we're going to go ahead and same setup is all the same. We're going to go ahead and factor it. And you have a 2 and a 2. Both of these are negative. Okay, and we're going to write this as, this is a perfect square trinomial, which does factor into a binomial square. All right, there's your square. Notice you do have a linear term again down here. All right, but you have 2 factors of that. All right, so remember when you have 2 of the same factor, you do have to start with the first degree and another fraction. You're going to bump it up to the second degree. So we're going to go ahead and do that. Okay, so you have your step 1, your step 2. We're going to go ahead and set up the form. This was step 1, factor the denominator only. Okay, so we're going to write the form and then multiply by the LCD. All right, so, and you don't have to write those steps there, but I just want you to see in the directions where it's coming from. All right, so go ahead, x minus 4. I'm going to go ahead and I'm going to use the binomial squared form. All right, and then for the, you have 2 factors really down there. All right, there's 2. All right, so you have x minus 2 to the first power, and then you also really have an x minus 2. You have to increase it and go as many fractions as there are numbers here. Okay, so I just increased by 1. All right, so then over here, you have your A and you have your B. And now our form is set up. So now I can take that entire thing, start solving for A and B, and then my goal is to wipe out the denominator. So I am going to multiply everything by that denominator. Okay, and then it will be cleared away. All right, we don't like working with those fractions. So here we go. Take the first fraction and multiply by this. Okay, remember when you multiply it by this entire denominator wipes away, and you will always be left over with the original numerator, always. Take the second fraction and multiply it by the LCD, and then 1 power of x minus 2 will wipe out one of those, so you have 1 extra x minus 2. So this ends up on being a times x minus 2. Okay, and then now you're going to take this one and divide it by this one, and look what happens. All of this wipes away, leaving you with your constant of b. Okay, all right, so for this problem over here, again, like I said, I am going to do this one a little bit different than the other ones. All right, and here is how you're going to do this. And this one, again, a lot of people just prefer this for 100% of the time doing it this way. And if you want, I recommend redoing the top 2 problems, maybe using this method. You might really like it. All right, so here's what a new method is going to be. This method, instead of finding convenient values, we're going to do what's called an expansion. You are going to expand the right-hand side. And when I say expand, you're going to multiply everything through. You're going to shuffle and put the highest degree, and you're going to count all the way down to the constants of all the values that you have. So expand the right, and we're going to do what's called a matching game. Okay. All right, so you're going to take and rewrite what you have. So I'm going to expand the right, keep the left exactly how it is, and I'm going to distribute that a, so I get ax minus 2a, and then you have that b. The next thing you want to do is you want to make sure that any term that has an x in it is next to all the other terms that have an x in it. And then you're going to group together anything that's a constant. So anything that has a's and b's without a variable, we know that this is the constant component of our equation. So now what I'm going to do is never ever move things left to right. This is like a brick wall. Nothing goes left and right when we do the second method. All right, so what we're going to do is we're going to compare. We're going to compare the term that has an x in it with each other. All right, so I like to kind of color code things. So this over here is the term that has x, and this term has x in it. And what we know is that the coefficients must be the same because both sides of the equation are the same. So what this is the linear term, x to the first degree. Whatever's the coefficient of x must be equal. So we call that matching. Okay, we're matching. I know that 1x must equal ax. So if you're solving this, that must mean that a must equal 1. And I don't even really set up an equation, you guys. This is what I'm just showing you. I just look at the coefficients. These coefficients must be the same. And even though there's not that 1 there, we know that that is 1x. So it's really kind of easy to do. I just matched it up. A equals 1. All right, so we're halfway there now. All right, now how do you get your b value? Now for the next parts, all right, now watch closely here. For the next part, -4 is the constant. Well, this right here, this component is the constant, so they match up. So I know that -4 on the left must equal -2a plus b on the right. Well, we just found what a is. A is equal to 1. So I can take what a is, put it right here. These are actually kind of fun. And you get a -4 is equal to -2 times 1 plus your b. So -4 equals -2 plus b. Adding your 2 to the other side, you get -2 for your b value. And there you have both a and b by playing the matching game. Okay. All right, so that would have been your step 3 using that method. And then finally, step 4, don't forget to go back, substitute a and b back into the original form here, and then you'll get your partial fraction decomposition in its final form. All right, so we have x minus 4 divided by x minus 2 squared. A is equal to 1 divided by x minus 2. And then you have plus b. Now keep in mind b is a -2, so I'm just going to write 2 minus, right there for the negative, all divided by x minus 2 squared. So again, if you're not seeing where I was putting that into, those values were put, a was put here, b was put here, and because it's a -2, this would be a -2 on top. Well, this and this becomes a negative, positive and a negative. And there's your partial fraction decomposition. Okay. All right, so I guess that is a wrap on this half of our video. What I would like you to do right now is you are going to, don't do this video yet. I want you to do some practice before you do those 2 problems. But there's some I'm going to have you skip just for now until you watch the other video. I want you to skip E. Oh, what else? I want you to skip F. And you should be able to do everything on this page except those 2. And then I want you to skip this B and this C. but you should do this now. So don't watch the other video until you have perfected all of the ones that I didn't circle. So you're going to do 1A, B, C, D, and number 2A, B, C, and 3A you're going to do tonight. And then, or whenever you're done with all that, you're going to move on, and you just have 2 problems for homework on the second set of notes. Okay? All right, so that is a wrap. You guys take the time. Please do this homework. It will be included in your 7-1 to 7-3 as well. All right, you guys. Have a great day. Thank you for being patient.